Okay, what I'm going to try to do in this video is to go through the Frostbite Falls case and explain a little bit. First off, here's the introduction. We got Frostbite Falls, this thriving community of 5,000. They're doing some economic development. They got a new company coming in, the Screaming Eagles. They're going to have 80 employees. They got an industrial park that they're going to be doing for 20,000. However, they're concerned about affordable housing. They've got other issues they're going to try and resolve. The local vacancy rate is 2%, but the problem is the housing is substandard. So you're contacted by the mayor who wants you, so you would go and talk to Wally Olson, trying to figure out what the problem is and why things aren't working. Wally explains that rental housing just, quote, does not pencil out, unquote. Local rents do not provide enough return on investment for anyone to develop new rental housing. As a result, you got a bunch of houses that are not worthwhile. And he tells you that he tried to do a deal last year. He gives you some specific information important to remember. A 20-unit bedroom house, 20 units at $10.50 per month, offered 1.35 at 7% interest for 20 years. So those are the important numbers to remember. Also, important development costs right here. The total is $2.625 million. That's what it's going to cost to do this whole thing, from the land, construction permits, everything. That's our total cost. This number will be important later on. Operating costs, also important, $83,000 total for our operating costs. Now we're going to transition a little bit and we're going to analyze this case. So assignment 1, question 1, prepare an operating pro forma through NOI for this project. Assume rents of $10.50 per month, 5% vacancy rate, and the estimated operating expense. What is the NOI? So we're going to use this developer spreadsheet and we're going to start working through it. So we're going to zoom in a little bit here on the revenues on year 1 and start working our way down. First question is gross residential rent. You figure that out by taking the rent per month times 12 months to make it annually times the number of units. So like the question says, assuming a $1,000 50 per month rent times 12 months to make it annually times the 20 units, we get $252,000 as our gross residential rent. So we plug that number right here under year 1, gross residential rent. The problem doesn't give us any commercial rent or tenant contribution or other income, so I'm just putting dash marks there to represent 0, or at least acknowledging that I know that they're there, but that we're not counting any numbers. So then gross income, that's going to be your gross residential rent plus those other units, the commercial, the tenant contributions, and the other income. So because there's no other contributions, this number is just coming down. Important to keep these distinct as we looked at the next part of it. Vacancy residential, the next line right here, you're going to be minusing that away. We get that number by not looking at the gross income, but looking at the gross residential rent. That's 252 in red up here, and we times it by the vacancy rate. We were told earlier in the problem that there's a 5% vacancy rate. So 5% of 252,000 is 12,600. So we plug that number in. Here you'll see a lot of these numbers are rounded. You'll see a little bit of me going back and forth. If you're going to round them, you should round them. If you're not going to, write them all out. But just for clarity's sake, I'm trying to keep it clear. Same thing for commercial right here. This number wouldn't apply up to this gross commercial rent if we had a vacancy rate, but here we don't have anything in the facts for a commercial rent, and so we don't have or a vacancy rate, so we have another dash or 0. Okay, so now use this equal sign, a good help for you to find the effective gross rent. What we're going to do is we're going to add the gross income, in green, gross income, minus the vacancy residential, which is the 12,600, and we would minus any vacancy commercial. So we get the 252,000 minus 12,600 minus 0 for equals 239,400 for our effective gross rent. And that's blue, we'll plug that in right there. All right. Now the operating expenses, this also came from the facts earlier. If you go back up in the slides earlier, you'll see that operating costs we were told is $83,000, and in this problem right here we were told to assume his operating expenses. So we plug that in purple, 83,000 right there. Reserve deposits, again, we're not given in the facts, so we're going to go ahead and leave that as a dash or 0, acknowledging that we know that's there, but no numbers. So now the big drum roll. Here's our net operating income, one of the most important numbers in all of our class here. We're going to take the effective gross rent, that's the blue right here, minus the operating expenses, and we'd minus any reserve deposits. And we're going to end up with $239,400 minus the $83,000, and that gives us a net operating income of $156,400. We'll plug that number in right there. So go back to the question. What is the NOI? The NOI is $156,400. So we've solved that one. All right, moving down further on the sheet here, we have the question 2. What would be the debt service on a $1.35 million loan at 7% interest for 20 years, and how much cash flow would the project generate? So we have two different parts to this problem. So we're going to look at first debt service, and then we're going to figure out cash flow. Debt service is when you take the amount of the loan and you times it by the constant. The amount of the loan is $1.35 million. We got that up here from the problem set and from what we saw earlier. And the constant we know is 0.0931. You can find that on page 90. It's in the table of, you remember, there's about from pages 89, 90, 91 that show you the different amount. You take the 7% on the left-hand row side, and then you take it, look for the 20 on the columns, and that's where you'll find your constant. So you take the loan amount of $1.35 million and you times it by the constant 0.0931 to get a total of $125,685. That is the debt service on this project. Now, if we had other loans, we would plug them in, but they're not applicable. In this case, there's only one loan. So our total debt service, bring this down here, you would add these numbers before, but now since there's no number here, we're just going to the $125,685, just gets brought down for our total debt service. Cash flow is then taken from and you again use these equals and these minus signs as help if you're wondering what to do next. Is the net operating income, this number right here, the $156,400, minus the total debt service, which is the $125,685, for a total cash flow of $30,715. Again, you're taking this number right here, minusing the total debt service for a total of $30,715. Plug that number in there. All right, so that should answer question 2. What's the debt service and what's the cash flow? Debt service, cash flow. All right, those numbers are plugged in, looking pretty good. Moving on to question 3. Assuming a $1.35 million loan, how much equity would Wally have to put in the deal to make it work? What would be his cash-on-cash rate of return? And is this a good deal for Wally? Does it pencil out? Okay, so we have 3 different parts to this question. What's the equity? What's the cash-on-cash rate of return? And is this a good deal? All right, we'll take this one step at a time. First thing we're going to look at is the equity. Okay, so we're moving a little bit away from the spreadsheet, and we're looking at kind of more big picture. The first thing is the project costs minus the loan amount. That's how you determine equity. Now, where did project costs come from? Go all the way back up to the facts of the case in the introduction. You'll see development costs. That's the total product cost. This is how much it costs to do everything. $2.625 million total. So that's where we're going to get this number from. Our project cost minus the loan amount. We know that we have a loan, $1.35 million. So take the total cost minus the loan amount. That's how much equity Wally's have to kind of put into it. So that's their $1.275 million. That's where we get our equity number from. So using that equity number, and the cash flow number, we can get our cash-on-cash rate of return. That's done by taking the cash flow, the $30,715, dividing it by the 1.275 cash equity for a total of 0.0241. And so turn that into a percentage, and that's our cash-on-cash rate of return of 2.41%. And so that's the answer to question 3. We've got our equity, 1.275. We got our cash-on-cash rate of cash-on-cash rate of return, and then we've 2.41%. And then the overall question: does this pencil out? No. 2.41%, while it's better than a checking or a savings account, is probably not worth the hassle of going through everything. So this is not a good deal based on the current circumstances. And we're done. That's the end of assignment 1.